Hello everyone, welcome to another video of System Design Masterclass. As you already know that in this particular series, instead of discussing the abstract system design components like what is a load balancer, we actually talk about the real world constraints and try to solve the real world problems. So today we are going to look into a particular interview scenario in which you are actually getting interviewed for a staff engineer role in a fintech company, let's say Stripe or PayPal. Okay, and the scenario is let's say you have a mobile application, okay, and you have one API server. So on the mobile application, currently you are seeing a pay button, let's say pay $50. Okay, so as soon as user clicks on this button, then the request will leave the mobile application and reaches the API server. So our API will try to process this request, and after charging $50 to the customer, one acknowledgement is sent back to the client. Now, as you know, that mobiles have a weak network, right? So let's say in this scenario, this acknowledgement request is not able to reach to the client. So client might get panicked, right? So let's say user clicks this particular button again. Okay. So if there is no protection available on your API server, okay, then in that case, if there is no protection, then you might think that it is another request that I have to charge, right? Then you can actually process this request and you can try to charge again. So in financial system, this problem is known as double charge problem. So in such cases, how will you restrict the customers to get charged multiple times for the same request? Okay, so you can actually pause the video for 2 minutes and try to think the solution for this problem. Okay, let's come back. So for some of you, it might look like our standard duplication problem, right? And you might think that before proceeding the payment, we can check the database to see if user has made a payment recently, right? So maybe in the last 1 minute. And if you get a response from the database that yes, this customer has made a payment in the last 1 minute, then you will flag that another request as the duplicated request and you will not charge the customer, right? That might be a solution. So this approach is known as check and then act because in this approach, we are actually trying to check the state in the database. And if it is not a desired state in the database, then we are acting, we are processing the request, right? So let's try to understand this approach with a sequence diagram. So here we have the user, we have the mobile application. This is the payment API or payment gateway. And here we do have our source of truth, which is the database. And this is payment processor, maybe your business logic. Okay. So this is the first request that user has issued. Okay. From the mobile application. Then we will send one post call to our payment API gateway to charge this customer with $50. Okay. Now, as I said, we are trying to check the state in the database. So here you can see we are issuing a query against our database for this user ID. So I'm saying select star from payments where user ID is equal to 123 and this particular condition, right? So this condition will actually try to get all the data from the database which is available for this particular user ID in last 1 minute, right? So let's say if we are getting no rows from the database, then we will consider this particular request as the first payment and we will process the request, right? And in another case, when user is actually clicked twice on the pay button, then uh, we will get some data from the database, right? And we will flag this request as the duplicate, right? Then we can send a status as the 409 conflict and recent payment detected, right? So this might be the solution that you might come across, right? But let me tell you, this particular approach will actually not work here, okay? Because you have missed a condition or you have missed a situation which is known as race condition. So what is a race condition? So in a distributed system, checking state and modifying states are two different operations. So in the previous solution, right, check and then act. So what we did, we issued two commands. First, we checked the state, right, in database, and if it is a desired state, then update, right? This is what we did. So we issued two commands, and in our distributed system, these two commands or two these are two different operations basically. Okay. So if user clicks pay twice or double tap, then there will be two parallel threads that will get execute in the code. Okay. So let's try to understand this with a sequence diagram. So here we have the client. Here is our thread A, thread B, and the database. So in the first attempt, right, when user clicks on the pay button, then thread A will be responsible for processing of that request, right? So thread A will pick that request, go to the database and ask, hey boss, do you have any recent entry for this particular customer in the last 1 minute? And database say, no, I do not have. Okay. Then it will try to update the database. Okay. I'm saying it will try to update, right? So there might be a lag. There might be a time delay in updating the state of the database. Meantime, client or the user clicks on that button again. So this is the attempt two, right? And thread B will spin over and thread B will be actually responsible for completing this request, right? So simultaneously, thread B will go to the database. It will also check whether there was any recent update in the database by the same customer. So again, it will receive no. Why? Because thread E has not completed its process yet, right? It has not saved the data in the database. So as both of them has received no, then both of the threads will actually try to deduct $50 from the client, right? So this is how the double charge happens in the financial systems. Okay, this is the major problem, and this is known as race condition. Okay, so that is why the approach that we have taken previously, check and then act, this that approach is not actually going to solve our problem. Okay, so let's try to understand this scenario, or let's try to solve this with a separate approach. Okay. So in this one, we are going to discuss about the idempotency key. Before that, let's try to understand what is idempotent, or when do you tell that this particular operation is an idempotent operation. Okay. So if we try to understand it mathematically, then an operation is idempotent if applying it multiple times, right, does not have any impact. Okay. So let's say I have applied this particular function two times, but in database, it is not having any different kind of effect. Okay, like it is behaving like if you are applying it first time. Okay, so if we try to understand it with HTTP verbs, so what all HTTP operations are idempotent? Then we do have get, put, delete. So all these three operations are idempotent. Why I'm saying this? Because if you try to get same data from the database multiple times, it does not have any adverse effect on the database, right? If you try to update the same row multiple times with the same condition, it will not have any impact. Similarly, delete. You can delete the same row multiple times and every time you will get 200 okay response, right? So all these operations are idempotent. But what about the post? So post is not idempotent by default. For example, if you say insert this data in payments, right? So if I'm trying to insert a set of data in the payments table and trying to run it multiple times, it might actually create multiple records, right? So that is what I'm saying post is not idempotent by its nature. Okay. So in this approach, basically we are going to use the idempotency key. Okay. And using this key, we will try to enforce uniqueness at the infrastructure level. Okay. So if we try to understand the architecture of this solution, then we are going to set up a contract at the client that you have to generate one unique ID for every specific intent to pay. Okay. And it sends this in the header. Okay. This is how it is going to send. So basically, what is going to happen is we do have the client. Okay. So whenever a request will be generated from the client to the API, then every time they are going to generate and issue one idempotency key in the header. Okay. Then once we receive the request at the API, then definitely we will check for this idempotency key. And if it is not available in the header, then we will throw an error. Okay. But at the same time, we will try to acquire a distributed lock on that key. Okay. So what is a distributed lock? We will come back to that later. But let's try to understand this flow. Okay. So we'll lock that particular row and then in this particular case, we will use Redis as the store. Okay, so Redis has one functionality which is known as set nx. So set if no not exist. So we will issue this command because this is an atomic operation. Okay, so if that particular idempotency key is not available, then it will return one, and if it is available, then it will return zero. Okay, so if it is not available, then it will return one and we will process the request. Okay, we will charge the client and we will process the request. But if that client, that idempotency key is available in the Redis, then it is going to return zero and we will actually immediately return the cached response, right, to the client. Okay. So this is how financial system tries to solve the double charge problem. Let's try to understand this with a sequence diagram. So from the client, we will get the request, okay, along with the idempotency key. In the Redis, we will try to set or we will try to run this command set nx key 123 started. So basically what it will do is it will check in the Redis whether there is already a key is available in the Redis or not. Let's say it is not available. Then we will mark the status as started. Okay. And we have acquired the lock, right? And this particular operation will return 1. Okay. Our API will process the payment in this particular situation and it will return a success response, right? And here you can see we are getting 200 okay with that particular receipt ID. Okay. Okay. Now let's say if you gets back the zero from certain X operation, then it means lock failed. Okay. So it means that key already present in the database, or sorry, Redis, right? Then we will try to get that particular key and we will return whatever is the response stored in the Redis. That response we will return back to the client. Okay. So this is how the financial systems try to resolve these kind of issues using this Redis operation, which is known as set NX, set if not exist. Okay, this is one approach, or you can do the same thing using the database also. Okay, so basically using SQL unique constraints, you can try to resolve this problem. So now the question rises, why not normal lock or local lock, right? So you might have heard about mutex, right? Synchronized. So these are known as local locks. So these actually work within a single machine, right? But in a distributed systems, we have multiple machines, multiple core CPUs, right? So local locks will not going to work in a distributed system. There we have to apply a distributed lock, okay? And the distributed lock actually takes care of uh, or it ensures that only one machine or one service instance or only one request should access or modify a shared resource. Okay, that is why we are trying to use the distributed lock in this situation. And how to implement it? We can implement it using Redis or using database constraints. Okay, so now based on this particular scenario, right, there can be multiple questions. For example, how will you implement the distributed lock based on the database, right? Or what if after receiving request, Redis applies lock, right? But your application server crashes. So in that case, user will get timed out, right? And if user tries to click again on the payment button, then our request will try to check whether that key is available in the database or not. But every time it will get that key is available, right? It will get this status is started. It will not be updated to completed or success, right? Then in this situation, that particular key is always locked in the database. So how will you resolve that kind of situation or that kind of problem, right? What if uh, or what response you will send when this setnx has returned 0. For example, whether you will send 200 okay or whether you will send 409 conflict, right? Or let's say you have a merchant and two customer pays exactly at the same time. How will you update the DB so that there should not be any money loss? So there are n number of questions on top of this, right? How you are going to scale the system? What if Redis fails, right? What if your merchant is actually McDonald, right? So this is known as McDonald's problem. So in that case, we are going to use shards for writing as well. Okay, so all these kind of questions may occur or may so you have to solve these also. You have to understand what logic you are going to apply in this kind of problem. So so I have covered all of these problems and all of these questions into one of my book, which is System Design Masterclass, Volume 1. And this is actually dedicated for building financial systems. Okay, you will get how to solve all of these kind of scenarios in a financial system APIs. Okay, and you can see that it does talk about payment gateway, what are the race conditions, okay, how to make the API idempotent, right, and what are the different implementation patterns to create this idempotent API, uh, handling failure scenario, right? The problems that we were discussing. Okay, how to handle the concurrency. So here we will use optimistic locking or pessimistic locking. What are the benefits and drawbacks, right? The double entry laser problem, how to solve that, right? So all of these things I have discussed in more detail in this book. How you are going to scale the system. So today, let's say you have 1,000 customers. Later on, you have 10,000. Then you have 100K, right? So basically, how you are going to scale the system uh, to accommodate all of these customers, right? So this book talks all of these concepts in more detail. I will share the link, and yes, you will get 15% discount on top of it. Uh, okay, that's it for today's video.